The directions say to find dy dx by implicit differentiation. Let's take a look at example 1. Suppose we are given 9x squared minus y squared is equal to 1. What we're going to do is differentiate both sides with respect to x. So the derivative of 9x squared minus y squared with respect to x is equal to the derivative of 1 with respect to x. Well, the derivative of 9x squared with respect to x is 18x minus, and then the derivative of y squared with respect to x is 2y times dy dx, and this is equal to 0. So now what I want to do is solve for dy dx, and I'm going to subtract 18x on both sides. And when I do, I get negative 2y dy dx is equal to negative 18x. Now, getting dy dx by itself, I'm going to divide both sides by negative 2y. So dy dx is equal to negative 18x divided by negative 2y. But negative 18 divided by negative 2 is positive 9. And so this can be simplified into dy dx is equal to 9x divided by y. And that's how we do example 1. Let's take a look at example 2. Suppose we are given 2x squared plus x times y equals 1. And what we're going to do is differentiate both sides with respect to x. So we're going to take the derivative of 2x squared plus x times y with respect to x, and set this equal to the derivative of 1 with respect to x. Now, the derivative of 2x squared with respect to x is 4x. The derivative of x with respect to x is 1. And then I have to apply the product rule on x times y. So the derivative of x times y with respect to x is x times dy dx plus y multiplied by 1. And on the other side, we get 0. Okay, so from here, what I want to do is I want to isolate the term that involves dy dx, and that's this term right here. In order to do that, I'm going to subtract 4x on both sides. I'm going to subtract 1 on both sides, and I'm going to subtract y on both sides. And I get x times dy dx on the left side, and on the right side, I get negative 4x minus 1 minus y. So I can get dy dx by itself by dividing both sides by x. And when that happens, I get dy dx is equal to negative 4x minus 1 minus y, right? And we double check, see? And we're going to divide that by x. And I'm going to leave that right here. Now, one thing you want to do is double check with your instructor. Now, in the beginning, if you look at this original equation, I can explicitly solve for y in terms of x. And your instructor may want you to do that. But just bear in mind, in these types of problems, you may not always be able to do that. So it's just something to keep in mind. So this is how we do example 2. Let's take a look at example 3. Suppose we are given 2x squared plus x times y minus y squared is equal to 2. And so what I'm going to do is differentiate both sides with respect to x. So the derivative of 2x squared plus xy minus y squared with respect to x is equal to the derivative of 2 with respect to x. Okay, now, the derivative of 2x squared with respect to x is 4x plus, now I get to use the product rule again on x times y. So I'm going to take the derivative of x times y with respect to x. So this is going to be x times dy dx plus y times 1. Then I'm going to go minus, and then the derivative of y squared with respect to x is 2y times dy dx. And this is equal to 0. Now, let's go ahead and write this on the next page. So on the next page, we have 4x plus x times dy dx plus y times 1 minus 2y dy dx is equal to 0. So I'm just restating what was on the previous page. So I'm going to collect the terms that involve dy dx, and that's the second term, and that's the fourth term. And we're going to leave that on the left side of the equation. So x times dy dx minus 2y times dy dx is equal to. Now, I'm going to move 4x and I'm going to move y over to the other side. So this is equal to negative 4x minus y. The only thing left is we have to factor out a dy dx. And when I do, I get x minus 2y inside the parentheses. And on the other side, we get negative 4x minus y. And then to get dy dx by itself, I'm going to divide both sides by x minus 2y. And when I do that, I get dy dx is negative 4x minus y divided by x minus 2y. And you're done. We cannot go any further than this. And this was example 3. And with that, let's take a look at example 4. So on example 4, we're going to do the following. X times e to the y on the left side, and on the right side, we get x minus y. Just like in the first 3 examples, I'm going to differentiate both sides with respect to x. So the derivative of x times e to the y with respect to x is equal to the derivative of x minus y with respect to x. Now, on the left side, I get to apply the product rule. So I'm going to write down the first function, and I'm going to differentiate the second function with respect to x. And that's going to be e to the y times dy dx plus e to the y times the derivative of x with respect to x, which is 1. That's on the left side. On the right side, we get 1 minus dy dx. Now, I need to collect all the terms that involve dy dx. So x e to the y, dy dx, and if you don't mind, I'm going to put plus dy dx plus e to the y, right? That's this term. That's on the left side. On the right side, we get 1. Now, I'm going to subtract e to the y on both sides. And at the same time, I'm going to look at these first two terms and factor out a dy dx. And when I do that, when I factor out that dy dx, I get x e to the y plus 1. And then that's on the left side. On the right side, we get 1 minus e to the y. So let's rewrite that on the next page. We get dy dx times the quantity x e to the y plus 1. That's the left side. On the right side, we get 1 minus e to the y. And then solving for dy dx, I get dy dx is 1 minus e to the y divided by x e to the y plus 1. And that's how you do example 4. And that's a good stopping point. That'll conclude this video on implicit differentiation where we did 4 examples. Okay, thank you.